That's right. What's happening, everybody? Music Therapy Laz here, wearing my that pedal show toque. Is that what they call it? I don't know. Looks kind of funny. Looks kind of funny wearing a beanie like for winter with a summertime shirt. I think my battery's dying. It is. I could tell. So what's happening, everybody? Music Therapy Laz here. I did invite at the very last minute Johnny and Ron if they want to join me for this heady topic. And to be perfectly honest, I'm kind of a little bit out of sorts this morning. I pulled a back kind of rib muscle or something. I don't know. Kind of pulled right here. And I couldn't sleep very well because of it. And then somebody last night who lives above us, they have a baby, woke me up at like 3:30 in the morning, banging around in the kitchen, probably half in a daze trying to find the bottle for the baby. I've been there, I've done that. And so God, this morning I was just having such a hard time getting started. And thankfully I did do some of this research previous days. Actually, this topic is kind of really interesting to me. So let's see what you guys think about today's Music is Therapy show topic. Sometimes I like to call it MITS for short. It kind of sounds funny, but MITS, Music is Therapy show. MITS, right? This is MITS episode 12. Not like baseball mitts. Though I do want to go catch some baseball soon. So Alex, where you at, man? Let's set that up. My brother's been bugging me about it too. Anyway, welcome everybody into the show. Johnny is saying hello from the bagel shop. I think I bumped my microphone and it says I unplugged myself. Here, let me pull that a little closer. Anyway, the new microphone setup is going to be coming soon. That thingy right there, right? Got a really nice one of these Rode Gator. It's Rode. Yeah, it's Gator Frameworks. Really nice mic boom arm. And Ron, my good buddy Ron Gunner. That's not his real last name. He used to be I guess, do you still do that? Probably not, right? Gun instructor. Probably how to do everything with him, right? Clean him, put him back together again when you take him apart, when you're cleaning him, shooting with them, all that kind of stuff, right? So Johnny is having bagels. What's that? Is that bagel pictures? Yeah, it is. Look at that. Bagels. I love bagels. Dude, we had bagels yesterday. I got the Trader Joe's bagels, and we ran out of capers, so I chopped up some little tiny pieces to give it that same kind of caper kind of zing, with some cream. Everything's falling apart here today. Cream cheese, of course, and kind of veggies on it, and salmon, the lox, Yeah, Boomster Black is also in the house. What's happening, dude? That's the old age music muscle. Oh, old age muscle. Yeah. You read about that. I guess so. I don't know. I was, yesterday was a really, really nice day. I went out with my mom. We went down to downtown and we were protesting. That's what we did. That's what we do in California, right? My mom and I protested. It was a very nice crowd of people. Who is this? Johnny Bean. Oh, you at a library? Looks like it.
Library?
Yeah, that looks like a booster chair for. Oh, okay, because I see a bunch of books and stuff. Oh, you're at the bagel place. Sugar Rush. Oh my God. Dragon Burlesque, sticky sweet queer variety show. Well, enjoy, Johnny.
Laz, are we going?
Enjoy.
Are we gonna go?
I don't know. I don't think so. April what? No, I've got something going on that weekend, actually. The weekend of the 17th. But yeah, we're probably going to Lake Tahoe. So that should be fun. Thank you, Boomster Black. I don't know if I want that. I don't know if I want that title. Oh, you know what those are? Those are California banana slugs, right? You know about those. They're all over that area. And then we've got Wayne McConnell. Hi, lad. What's up, Wayne? Whoa. And then Matthew Stewart. What's happening? We've got Rock Daddy also in the house. Who else do we have in here? We have Magic Man. Magic Man, he likes this topic, I think. Right, this is an
Thank you so
interesting
much.
topic. We've been sharing notes on this topic. What'd you get?
I got a bagel.
What kind of bagel? Obviously.
Some sort
Then
of
we've
bagel
got
sandwich.
all of us, a big panel discussing, right? You don't want to join me on this panel here, Ron? You can do that if you like. And then Charles 75N, what's up, Charles? From the Chatting with Charles show this morning, right? I'm assuming you did that. I was busy trying to wake myself up and
Oh,
be
we got you
prepared
on
for all
camera.
this.
Running the light.
Uh-oh. Go after him, Johnny. Go get him. Ron was still waiting for the show, and he was one of the first ones in. And there he is. Let's wait for him to appear, because it just looks like a dark room there. There he is. What's up, Ron? Welcome to the show.
Not much. Thank you.
All right, I gotta go. I'll see you guys later.
All right. Ciao. Have fun at the burlesque show. Anyway. So if we're studying quantum, okay, here we go. We get right into it, right? BC Rich 581. If we're studying quantum mechanics, will the live stream have taken place already? It probably has in multiple universal, string theory kind of ways, actually. It probably has. In the past, in the future, in the present, all at once, everything. That's how it works, apparently.
Or it never happened at all.
Well, we're attesting to the fact that it is happening right now, though, right? So, evidence. At least we think. Burnt Relic, first one in. What's up, Burnt Relic? Right on. Dude, I keep trying to get your package to you. I'm going to give it to Johnny, and he's going to send it to you, because he told me he's going to give me your address, but he never did. And you won on one of the shows. I think it was 2 weeks ago. And I've got your little package ready to go. So I think Johnny's going to have to send it to you now, because he's been dropping the ball, as they say. So
Well,
Johnny says bye. All right, go ahead, Ron. Take it away.
I hope you have better luck with his address than I did. I tried sending something twice.
Oh,
First
to Burnt
time,
Relic. Okay.
First time it came back. Second time, I don't know
Well,
what
he's like
happened.
Schrodinger's cat. He's sometimes there, sometimes not, sometimes live. Might be a rabbit once and a mouse the next time, and who knows what kind of quantum, kind of physical reality he is in, right? We don't know. So we'll
Very
just send
true.
him a quantum present. He'll get
Virtual.
something.
Virtual.
It'll be a quantum virtual present. All right, that's the way it's going to roll. Well, here's the rule. I'm going to make a new rule. If I don't get an address from you within a week's time, it's going back on the board. How about that? All right. So you're the last chance. Burn Relic, send me a message today. musictherapylabs@gmail.com. Let me take a sip of my Bowie. Of course, you got to have a Bowie cup for this kind of a chat.
I just got my Hummer
Right
cup.
on. What you got?
As always, my Hummer cup.
Oh yeah, the Hummer cup. Did that come with the Hummer?
No, I bought it extra.
You had to bought it extra. They didn't even give that to you after you bought that expensive Hummer. Did you
No,
buy it
sir.
new or used?
I've had that Hummer for it was a demo, so I was the first owner.
Wow. So you're like that lady who got that first Civic that was redone, the Sport, and they wanted to make her be on TV, and she's like, no, I just want the car. And they're like, no. And she was like some kind of a high-end exec that didn't want herself out there publicly about it and stuff. And it was an interesting dilemma that Honda was having with her. But she wanted to be the first to have it, though, and so I'm assuming yellow.
Yes, it's yellow.
All right, right on. Yellow
And black.
Yellow and black. There you
Steelers. Interiors yellow and black.
Right. You're a Steelers fan, even though you live in Ohio.
Yeah. Well, I'm only 50 minutes away from
where were you born? You were born. You live in the house that you were practically born in, right?
Yes, I've lived in this house 40 years.
More than anyone.
Yeah.
Yep. Since forever.
Mm-hmm.
And ever. And ever and ever. So we are going to talk about quantum physics and music, because I think I like to do these heady, kind of deep, handy, Jack Handy deep thoughts kind of things on the show, because it's fun. And I really enjoy, that's probably part of my problem in life, if you want to call it a problem. I think it makes my life very interesting. I have a lot of interests. Interesting, right, Bernard? Yeah, I have a lot of interest. Hey, Marcel, what's up? Thank you for joining us from France. We were there last year. It was beautiful. The weather wasn't, 1 week earlier, it would have been perfect. We got there right when that big storm hit, and Europe had all this flooding and stuff going on. But we had a good time. We were actually on the Triumphant Arch when it was hailing.
Ah,
So that was quite a welcome to be up on the arch. That thing with the umbrella where it goes whoop the other way.
yep.
It goes like from this to that.
Yep.
That's what happened. It actually happened.
Then it starts
That's pretty
catching the
funny.
hail.
Oh, it was.
That's-
Yeah, we could have caught
So you're
the
around
hail.
going, oh, hell no.
We could have caught the hail and then dropped it on people down below. Anyway, but yeah, it was
Got the hell out of there.
Eternal flame over there. I don't know that. Did you know they have this eternal kind of a flame there that's there for the remembering the soldiers there? For the unknown soldiers, I think. Yeah.
Yeah.
They have that flame that's burning there, and I didn't even know about that, which was really cool. Oh, you're from Quebec. Okay, well, it's close enough. Oh, uh-oh. I don't know why I'm having issues with the internet suddenly. But quantum physics and music have a lot in common. There's this thing about string theory, and like, look at this thing.
Ah,
It's got strings on it.
I got a theory about that. Actually,
Right.
one of my favorite people to listen to is Dr. Michio Kaku.
Yeah, he's amazing. Yeah. Did you know that he like knocked out the power like for like an entire quadrant in his town because he
I
was
wouldn't
like
doubt it.
experimenting with something down in his basement when he was like a preteen? I think he was a teenager by
His
now. Yeah.
his goal
Yeah,
is
it was a middle
to
school thing actually.
his goal is to finish Einstein's within an inch equation.
Interesting. I haven't heard the inch equation. Within an inch equation. Are you talking about just trying to get the
He wants
theory
to
of everything?
he wants to solve it within 1 inch of an equation.
Oh, I see. So he wants to create the equation that's only that long,
Yes.
just
Yep.
like Einstein with the E equals mc squared.
Yep.
Well, he'll just have to make up acronyms for that, just like everyone else has in that field, right? Because the thing about math is when you get into that deep math, have you seen if you actually equate those things out into actual like numbers only, it's impossible. You can't even fit it
Mhm.
on one of those giant chalkboards where they're using a ladder and they're up there writing it like
Yeah.
that, So they have to make these acronyms of sorts, these little symbols that represent something, like M being the mass, right? E
Yes.
equals energy, and C is the speed of light, So
Which is pretty
who else-
fast.
who else is from somewhere like Quebec? Well, where's the rest of you guys from? I think Boomster Black, I think, is somewhere in the United States, aren't you? Or no, I think he might be actually from the Canadian Canuckistania, as we now call it. Oh my God. Anyway, yeah. So I pulled a muscle, you guys. I think that's what happened. I pulled a rib muscle, like one right below at the bottom part of your rib, right back here. I was doing something, and I pulled it, and I might have even done it in my sleep or something. Who knows? Because
Sure
I
you
didn't
didn't
feel
hurt
it until the
your
next
kidney?
morning. I don't think I hurt my kidney. How do you hurt your kidney? Maybe you buy too much of that stuff, right?
Possible.
No, because I wasn't doing any of that stuff really. I had one beer on Friday, and then yesterday, I think my sweetie had a margarita, so I had a little sip of hers, and then later that day, I had there was some leftover Coca-Cola from the Friday hang with my cousin Joe, who's here from Budapest, visiting and going to Vegas. He's actually at Vegas doing a tournament right now. Anyway, so he came by with my cousin Suzanne, the one who has MS, who was able to get up and around, and it was really nice to see her. And she's such a wonderful spirit. I love her. She reminds me a lot of that kind of Jason Becker type person who okay, so this is something that happened to me, but it's not going to define me, and I'm just going to be a happy person anyway.
And that takes
isn't that
a
amazing?
special person, because I don't know if I could do that.
I always wondered what would happen if I would have been completely blinded as a child when they put that gas mask on my face and blinded my left eye. They could have blinded both my eyes, and thankfully it only blinded one of my eyes. But I always wonder what happened if I was blind. Would I be like Ray Charles? You know. Here, hold on. Let me get the right bit of sound.
Ronnie Millsap.
Let me get a sound. Gotta get the right kind of. See, I'm really out of it right now.
But how
little loud,
cruel,
right?
how cruel,
Sorry.
how cruel is it to have a blind man's have a hit song saying "There's a stranger in my house, somebody I can't see."
Right.
I always
Yeah.
thought that was like really weird.
Well, he was probably trying to get an emotion, a feeling across, you know. Yeah. But I think it was metaphorical too. Right? maybe the person he was with became a stranger to him. I don't know. It could have been anything like that, right? Patrick, what's up, Patrick? We got all kinds of new people popping in. Thank you, Patrick,
Hello,
for
Patrick.
jumping in from Alberta, Canada. So we got a lot of Canadians jumping in. You know why? Because I think some of you guys are coming over from Charles's show. Who'd you have on for your guest, Charles? Tell us. Might have had a Kanakistanian on the show. By the way, if you guys don't know my good friend Ben Coombs is the coolest dude, one of the coolest Kanakistanians I've ever met. Honestly, man, that guy's like a brother from another father and mother kind of connection. You know, when we first met, we just hit it off as friends. And Ben Tom, another dude I wish I could meet, because that's another guy who's gone through a lot of stuff physically and otherwise in life, you know. And from what I understand, is also one of these people that tries to stay positive, you know, even though he can get a little bent out of shape at times at people. Hence the name Magic Man. It's funny when it's spelled. You crack me up, dude. But yeah, man, you know, spelled. Okay, well, spelled, you know, that's different kind of American language, right? There's languages like that. What's up, William De Silva? Or as Johnny would say, Salva. Johnny's having bagels right now. Anyway, so you guys want to jump into this topic or not? We keep talking all about this other stuff. It's already 10:30.
Go for it.
And I was late. So yeah, so quantum physics, okay? Who knows what quantum physics is about? I put some links in the description if you guys want to learn about this stuff, but we're all talking about quantum computers lately. That's the biggest thing, right? Quantum computers, quantum, you know, take over AI of the world. Like if AI creates a quantum computer, it's going to rule us and all this kind of stuff. And really what quantum computing is about, and it was discovered, is what the scientists like to say. They discover these things. They don't invent them. They don't create them. They discover these phenomenon in nature, right? Through math, which is a language that they use to describe what they're observing, all right? And the quantum world is weird. The deeper they got into the math of how they're observing things going on in the universe, right? And now they've, through the last, especially since the 60s, they really jumped back into quantum computing and quantum physics. Really, quantum computing has a lot of potential to do a lot of great things, right, Michael? Yeah, here you go. So when you get small, it's no longer yes, no, it's probably hey all. That's right. That's exactly what it is. So yeah, so quantum computing and quantum physics are okay. So one is working off of the other. So in other words, they're trying to figure out computers that can calculate things at the same level as quantum, which is what we see in nature. So the difficulty we've been having in trying to understand some things that we see and observe in nature is because it doesn't make sense to us in our everyday 5 senses that we have. So we create these tools like microscopes, telescopes, things like that to see things at distances and see things in different physical forms that we wouldn't see otherwise. We create atom smashing, you know, giant hadron colliders to crash atoms into each other so we can break them apart and see the particles that are below the very atoms that we first
create a black hole that will suck up the Earth with the Hadron Collider.
Yeah, I don't think that'll happen.
I think it would have happened by now if it was going to.
Well, you have to understand that they have to put a lot of energy. There's a lot of energy required to create these things. As you all probably know, you guys probably should know, a black hole is basically, from what we understand, a collapsed star. And not all
Mm-hmm.
stars collapse. Some actually dissipate, but some of them do collapse. It has to be a certain kind of star. I don't want to say which one it is because I can't remember exactly right now because I'm out of it. No good sleep last night. But anyway, bottom line is that that energy is massive. And one of the ones that I was watching last night and then even the other day, and what got me to think about, let's do this topic for today, is how they're finding more and more evidence that it's very, very likely, if not pretty much 99.9% very likely, that most spiral galaxies like ours, large spiral galaxies, are spiraling. Just like you have a drain, why does the water go spiral down the drain? Why doesn't it just go like this? Why doesn't it just go straight down like that? Okay, why is it spiral? Well, gravity, one, and two, the earth is spinning. So you've got gravity and the earth spinning. So if something's pulling it down and you dropped water here, but as the earth is turning, the water is gonna, see what I mean?
Did
So
you
that's
ever
how that's happening.
did you ever see the video of the little village on the equator where they had the line and they had water here and water here, literally like 8 inches apart, and one spun one way and one spun the
Oh yeah,
other?
I know about that.
Yeah.
Yeah, that is really, really interesting, and that has to do with the electromagnetic gravitational
Mm-hmm.
forces on Earth. And we don't come across these effects in everyday life, and that's why it's so shocking to us. It's so hard for us to grasp or understand because it's not like, oh look, I'm picking this thing up, but this is actually not a solid object. Really, we call it a solid object because,
But
right?
molecules are
It
always
feels,
moving.
but there's more space here in between than there is actual physical, atoms or properties. So that's the things that hold these things together on the atomic level, right? That's what's fascinating. And so quantum physics is all about how these things are held together. It's about the very small, but at the same time affects the very large. So when you're talking about understanding a supermassive black hole that is like the 10 billion suns large sizeness, right? That, I think it's somewhere around 10 billion, if I remember them, if I'm quoting correctly. The supermassive black hole that they observed by data they believe is existing. They have to still prove it, but they're working on it.
Well,
It's hard to see something like that, but
well,
but you ever see it?
last year was the first time
Right,
that they saw light escaping from a black hole, which
right.
for years it was nothing
The
could escape
corona.
it. Yeah, they were like nothing
Well,
can escape it. But
it's not even that it's escaping as much as that is the coronal section of the black hole that all the gases and stars and other things that it's getting sucked into are spinning around it, and then eventually gets sucked in. But the weirdest part about this is how it works when it comes to our relative time to observing it. So we're observing it in a relative time. It's our time relative to me and you and us here on the planet from whatever distance we are, right? There is that thing that they call Hawking's, radiation, and that's what you're talking about. And that's not, I don't think that's what they got a picture of, but they did get a picture of the what they call the coronal, you know, mass or whatever around it, kind of like how the sun has a corona.
well, the picture I'm talking about actually showed like a beam of light,
Mm-hmm.
and it was the James Webb
Right,
telescope that got it. So
right. That was their first actual
yeah.
proven evidence through the infrared that they were able to take a picture. And I've seen the picture of it. It looks kind of cloudy. Let's see if I could find one real quick for you guys. First actual picture of a black hole by James Webb telescope. There it is.
Event Horizon. There you go. It was a good movie.
Yeah, it was pretty wild. That was a scary movie.
Yeah.
So that's not blurry. That is actually how it looks. I'm not kidding. So the interesting thing about black holes is that things are going on there that they. Oops. Oh yeah, accidentally pushed the button there. That's funny. No, hold on. There's a spaceship one here. All right, the things that are going on at and around a black hole defy our classical physics understanding. So we're talking about Newtonian physics, like you drop the apple, gravity falls down. You have different objects that are shaped differently on Earth. They fall at the same speed because of the atmosphere that we have, right? You can have a small rock, a big rock, doesn't matter. They both hit the ground at the same time, even though one's heavier than the other. And that's like, how is that working? They proved that on the moon when they landed there, and they dropped a feather, and they dropped something heavier like a rock, and the feather, of course, dropped at the same speed. Where I'm saying it opposite. Whereas here, the feather will take a lot longer to get down because atmosphere and its weight. It's not just the weight; it's the distribution of the weight, across its surface, right? And there's drag involved. I was having a conversation with when my family was over here visiting with my cousin Joe about if you wanted to launch rockets out into space, it would make sense to build the rocket stations that you build the rockets in space, or at least take pieces up there if you're going to build a big one like the Star Trek Enterprise, for example, right? You want to build it, or like the Death Star, you build it out there, because once it's out there, it doesn't take as much energy once it's off the Earth to actually launch. So you'll need less fuel to launch if it's already up there, right? So let's say you do a bunch of little launches, or you do whatever manner of getting the stuff up there. But the point is that the further away from the Earth you are, the less gravitational pull, and also less atmosphere that you have to go through, which causes drag. And if you're already out there, then you can do all your launching from there, and it takes less energy, right? So you get all the stuff that you need to do launches up there, put the giant spaceship together up there, and then you launch from there. Now, I was telling her that it would be cool to have bases on the moon. Part of the reason is because you're already further away, and that has 1/60 gravitational force of the Earth. And so if you do want to launch off a surface, you can launch off the surface of the moon. But then you still have to get to the moon, land on the moon with all this stuff, and then launch from there. It doesn't make sense. It makes more sense to just put everything up in orbit. Well, maybe you can put it up in orbit at the moon. And that's another way. So there, you have bases, places where you can have structures and then have bases. And then you can have space bases out in space, or orbital, space satellites, or whatever you want to call them, stations, and then do your launching from there. So it just makes sense to me. And she was saying, no, actually, it's better if you have the launch from the actual surface of the moon, because then it has something to propel against. I'm like, I don't think it works that way. I think that you want to be away from the gravitational pull of this object already. So if you're already in orbital, space, there, you're not.
What causes gravity?
Oh God, I do not know. I mean, mass.
Well, I mean, but, why are we being held on Earth?
Why don't we fly off as it's spinning at 1,000 something miles an hour, right? 4,000.
So I always grew up hearing all my science teachers saying that the spinning of the Earth is what creates the gravity.
No, I don't think that's true, because the moon has gravity and it does not spin.
That was always my question to them. Okay, then how come that we always see the same side of the moon, yet it's got gravity?
Right, because it's not spinning. Yeah. It has no center core of sorts like ours, and part of the reason why the Earth spins is because we are going around the sun. The sun has gravity on us. We have a liquid core, a molten liquid core that's moving, and that's being also pulled by the moon and by the sun. The two biggest objects nearest us that have gravitational pull on us, because we're not getting pulled by, say, Mars as much or something else, right? But definitely the sun is holding us in its orbit, and so the heat from the sun keeps the liquid, molten lava, hot to some degree, right? And because it's moving, that has a lot to do with our rotation. Now, why we're at an axis rotationally, that's a really interesting thing. Some people surmise that was when this other big chunk of something hit us and became the moon, or knocked off the part of what became the moon, and that knocked us off axis. But it could be other interplanetary system kind of happenings. Some people think that there was a planet X or 10th bigger planet that was like a big exoplanet that's out somewhere where we don't see it.
On a
And
3,600-year orbit of the sun.
yeah. And what's really interesting about this one is that they say if you do the numbers,
Noah's flood.
then that makes sense for everything to be in the orbits that they are. But without that planet being in the planetary system, it doesn't make sense. So it has to be out there somewhere, and some scientists are trying to find it, but it's a big sky.
Yeah, you ain't kidding.
Oh, yeah, right. The moon pulls away from Earth. Yeah. It's
Actually,
Nabu. Okay, that's the
it's
name of it,
going
yeah.
what?
It's Anunnaki, the Anunnaki
Yeah.
planet. Hey, what's up, Edina?
The moon's going what? A foot away, a foot farther away every year from the Earth. I think that's what it is.
Interesting. So, but on the quantum level of things, right? Gravity is a very important part of this whole quantum fields, quantum, the universe is, and why they call it quantum, that's another thing we should probably bring up. Let's say you're creating a computer that counts things, right? And so you have all the data that's in your computer, and basically it has these little switches or transistors of sorts, these little circuits that are basically going on and off. That's your 1 and your 0. And it's calculating things by, is this correct? Yes or no? Is that now correct? Yes or no? Is this correct? Yes or no? That's a standard classical computer kind of thing. It has to go through all those calculations. It doesn't have memory like we do in our brains. We have a quantum, like lightning fast ability to remember something like, what's your daughter's name if you have a daughter? And you just know it. You don't have to go through, okay, I have 5 children. This one came first, that one came next, this one. Okay, it's Susie. It just comes to you like that, because the way things work on the quantum is that there are all these probabilities that then collapse to a single, point at which we are then observing it or making note of it or whatever you want to say. I remember when we were taking a psychology, biology class, I used to coin it psychobiology because it made it funny. We went deep on some of this stuff because Jim Clifford, the head of the department there, really tried to give us a little more information that we typically wouldn't get in an undergrad class like that, because he was trying to get us excited about this, about biology and psychology, and then things like the quantum, and how is this happening, and how is it that we have consciousness, for example, and the hard questions. There's those things they call the hard question, right? And as they further develop better tools, they will observe different ways of understanding how the universe works. And they did the double slit experiment and found out that, oh, these aren't just particles that are just at one place. They actually will disseminate, and show wave-like activity. So in other words, these things aren't really electrons, photons, whatever. They're not just a particle flying around. Like they have those pictures of an atom that looks like planets going around the sun. That's not how atoms work. There's actually almost kind of like a fuzzy, like hazy, looks like fog around the atom in the center, right, of electrons, and there's different levels of energies of them, and they're everywhere all at once until you measure it, and that's when you measured it at the point where it was when you measured it. So it's never static.
Isn't
so
that
when
what
you measure it as a static thing, but it's not.
is that where they get into what they call fuzzy logic?
That's a good question. I think no. I think fuzzy logic is when they have logic that does not make any rational sense. But maybe you're talking about like fuzzy science, yeah, because a lot of people who didn't want to, even Einstein said, he didn't agree with it, what was going on when he started to observe some of these things like black holes and whatnot, and the idea that a particle can be at two places at one time. Well, maybe it's because it's not actually a particle, but it's a like frequency like this, So that's a wave.
That's 3,000 miles away right there.
I just created a wave of air movement, basically, off the plucking of a metal, string that's taut between two different, static pieces of metal or whatever. Well, I think it's graphite and metal. But yeah, but the point is that he called it spooky action at a distance
Mm-hmm.
because he couldn't understand how these things could be entangled. And now we're talking about entanglement. Entanglement is a quantum physics term, and it's the term trying to describe how two things can be at the same place once. But we just did it because you just heard it there.
Mm-hmm. 3,000 miles away.
And 3,000 miles away, and you instantly heard it,
Mhm.
you know. And we are projecting via the speed of light here by the internet, right?
Pretty close.
But I mean, you know.
Yeah.
So there you go. We proved it. Show's over. No,
Where-
I'm kidding.
That was your quantum fuzzy logic black hole
We proved it. Anyway. So the point being
hyperdimensional.
is how if we had Einstein in the room right now, because they had telephones back then, didn't they? They had
Yeah.
telegraph and stuff like that. So they knew electrons can go pretty fast because they were basically sending an electric signal. That's like a, you know, electricity going pep, 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 pep. That's all they're sending is electrons. And that's how fast electrons were moving at the speed of, I guess, light. How long did it take for those electrons to go?
Which is the speed of light's what, 189,000?
I don't know. It's something like that. It's pretty dang
189,000 miles per
Let's find out.
second or something like that.
What is the actual speed of light in miles? Yeah, 186,000 miles
That's
per
close.
second. You know, that's a rounded off number, by the way. About 300,000 kilometers per second. Per second.
I'm
Second.
just going for the
Yeah, not hours. per
considering
second.
I haven't had a science class in many
That's pretty good.
years.
Good job. Yeah. So yeah, right. Magic Man. It seems impossible to prove. Let's see what when the photons, right, react differently when observed versus not observed, and this is something that they have proven. Believe it or not, Magic Man, they have actually proven it because they've done observations over and over and over again, and they come up with the same thing, right? And that is because, and this is what I said in that class, and I said, well, of course. It's going to seem different. Let's say it's moving like this, and it's moving so fast that you can't really easily measure how fast it's moving. But you say it's moving here. You take a picture here. Take a picture here. Take a picture here. No, take a picture here. And every time you observe it, you're stopping. Your observation is stopped. It's still going, but
Yeah.
your observation is a frozen snapshot in time, just like a movie reel or something like that. You got all those reels. You have the refresh rate. Right. So basically
Flicker.
what we're So what we're talking about is you're taking a measurement while it is not static, you're creating a static moment. And so your observation of it is not over its entire thing itself. It's whatever it is. You're only measuring it at that moment with the tools you have, which are really, really limited. So now we're starting to understand things better. Go ahead.
Like Magic Man saying, if it's different from when you're observing it to when you're not, how do you know? If you're not observing it, how do you know it's different?
Right. So we can get into the Schrodinger cat thing. So this is the thing is that how you know what it's actually doing is like when they did the double split experiment, they shot enough protons or photons, whatever, photon torpedoes through the two slits, okay, against the backdrop or whatever you want to call it a wall or whatever. Let's say they're paintballs, and you just shoot one paintball and it's there. And you're like, okay, they always land there. No, you keep shooting paintballs and then they start spreading out. And then they have this, like this, I forget exactly what it's called. But it's the, you see it all across. And then you notice that, oh, this seems like these particles are actually performing or acting like, or they're behaving like a wave. And there's these how waves, when they intersect, like if you have one slit, it just goes like that, right? If you have two slits, it's going and they're waving into each other, and then the waves hit each other, and then they create these,
collage.
Patterns. Right? You could call it a collage, right? Interference pattern. That's what it is. So you have this interference pattern, and then they were able to understand it. Okay, this is really more a wave, right? Than it is one thing flying in a direction like a particle, right? So we first understood it in Newtonian physical, theory of physics as thing that we can see and touch and feel, and and it's moving that way, and then it hits there. But we then got better tools and better understanding of how these things happen with these better tools, and noticed that it's acting like a wave. So then they started to get smarter about this and started to understand more things as they move around in the universe, and understood that the electrons and protons and whatever is flying around an atom, those things aren't like orbiting, like little particles orbiting like this. They're actually just there. They're just there, resonating kind of like a frequency, like a wave pattern around it, right? And then they die down, or break out into different levels of energy, and that's what makes different atoms different, depending on how many, whatever, or in the nucleus.
I think science in a whole will never be completely understood by humans.
Yeah, William De Silva explains it here. He says that, yeah, they did it with a medium that captured the photons, and they could see where the photons went, right? And they were able to measure, over many, many, shots of photons, single shots. They went all over, and then they spread out, and they created this wave pattern, which is really interesting. Is that my friend Martin? What's up, dude? No worries, I was late too. Very late today. Yeah, and that's exactly the argument I had, that you're disrupting the actual flow of it by taking a picture of it or whatever. But you can read it up on this stuff. They have the science is proven. But we're gaining more understanding of these things as we're getting deeper into it. And the quantum of this all, if you want to see a really interesting movie on this, it does a fairly good job in a way, but at the same time, it makes things kind of a little bit too magical and freaky. The Schrodinger cat thing is the "What the Bleep Do We Know" movie. That's at least 15 years old, if not more. That's been out for a while, and it does an interesting, job of trying to explain, the universe as we're better understanding it now. But we are getting better at proving these things with the tools as our tools get better. And the thing about it is, it takes a lot of power to run these tools. So another reason why they are really trying to work out, things like fusion, like they did over here in Lawrence Livermore Laboratories, is because if you can create energy that's more from less, right? So you start with less energy and create more with it, then you can create a energy source that is revolving on itself. So it's self-feeding energy machine. In other words, it could just keep going, right? But how long can they have that fusion moment, like in the sun? That's basically, you're trying to create a sun power, right?
Yeah.
You have to have some energy coming from somewhere to then create that. And I think that in the future, we might actually have, if not down on the Earth, we might actually have in space collectors that, do the fusion out there and send it to us in a beam. Something like that might be.
See, once you do that, you're getting into a type 1 or type 2 civilization.
Yeah.
Right now we're type 0.
We're type 0.25 or something at best.
Well, we're type 0, but
right.
but within 100 years we should be a type 1.
That's some of the theory there, right? Yeah. So science moving forward, right? Yeah. 50 years ago, when I went to school, there were only 103 elements in the periodic table. Yeah, exactly. That's exactly right.
And so element 115 was Bob Lazar from Area 51.
There you go. That guy's an interesting character, right?
Yes.
He's got some stories. But there's a PhD lady on YouTube that does the experiment. Super cool. Yeah. There's a lot of people on. That's what's great about YouTube. Hey, Carswell Coast. Or is it coat? Okay. The word quark, an elementary particle, right, was taken from a novel by James Joyce. There you go.
He was also a character on Deep Space Nine.
Yeah. Was it Quark?
Yeah. He ran the bar. The Ferengi. See, I'm full of useless knowledge.
That's right. Yeah, my mom loves that stuff. I watched it a little bit. Yeah, I thought it was Quirk, not Quark, because he's kind of quirky. He loves gold and money, though, doesn't he?
That's it.
All right. Yeah, one universe. Yeah. Yeah, we don't know. We don't know if there's just one universe, and that's what Michio Kaku and a lot of these string theorists, the math, it keeps pointing in the direction of multiverse or multi.
Well, if you look,
tell me what you think.
If you're looking at like how they're talking, like right now watching this show, I could say something, and you answer it one way, and then if you. How did he explain that? So if I said yes and you said no right now,
okay,
and then that would create another offshoot of another universe where you would said yes with me, and then another one where I would have said no with you.
Right, but that would only be two different universes.
Well, but every little action or decision would create another one. That's why they're saying they now admit it's multiverse.
Well,
and quantum is proving that.
They're theorizing this. Now so I tend to be in the camp a little bit more with what some of these physicists, I tend to be in the camp of the realists. And what I mean by that, and maybe not, just like I'm not a Democrat, I'm not a Republican, I'm a progressive. But what does that mean? Because there's progressive Democrats, there might be progressive Republicans. So how I define myself politically, it's a similar kind of thing. So what I'm trying to say is that when it comes to realists, I think that they talk about everything that's on the quantum, right? The quantum universe is probability. That there are all these probabilities, and then when you make your measurement, it collapses to an answer. That's weird to me, of course, and it's weird to them too. They all admit, all these people say this is weird, but this is what it's telling us, so we're going with it, But it doesn't necessarily mean that there are actually all these different universes actually in existence all at once. It might be that all the probabilities are there for all these different, universes. But our universe that we exist in is in existence because of it being the one that worked out. The probabilities all together worked out to create our universe. That doesn't mean that there's a bunch of other ones simultaneously all at once. It just means that with all the probabilities that are out here, like right now I'm reaching, okay, I'm not going to look. I'm going to reach my hand toward my cup and hopefully not knock it over. Okay, I grabbed it and I'm sipping from it. Now,
yeah, they were saying like every decision you make.
Good probability if I didn't really know the distance of where it kind of was, and I was just going blind, I could have knocked that cup off the table, and that would have been a completely different probable universal situation. There is a different reality that would have occurred and could have happened, but did it? No. So the one that happened was the one where it all collapsed, as they say, into this one reality that now occurred again and again. Here we go.
So, and then Dr. Kaku saying that at every decision you make is a pivot point for a new universe.
I don't think it's a new universe. I think it is the universe, and that's my argument. I say that relatively, it collapsed to that one, and every time something happens, it collapses to another one. Because in my mind, if that was true, anything could happen, and everything happens, and everything's all at once happening, then it would be complete random chaos, which is kind of how we see things on the very lowest particle level. And that's where the quantum physics things really started off. It started off there. Now, how is this all related to music?
Spooky music.
It's in the math, man. It's in the math. It's when you talk about quantum, you have, okay, let's go ahead and play it.
And there's only 12 notes. So
let's do this. And these are only 12 notes. That's right.
There you go.
Okay, no.
Dun, 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 dun.
All right, so this is a C. This is not middle C, is it? There's middle C. But here's C. Okay, do you know your intervals? You know this one.
Yeah.
That is an octave. 8. In other words, right? 8 notes
3,
here.
4,
Now
5,
we're not
7,
going
8.
flat or sharp. We're just going 8 notes on C. No black notes on the piano, right? In guitar, it's different, right? In guitars, right? You're going to be going
Yeah.
up half steps, down half steps, okay, chromatically, all right? Now we're getting into some of those terms, chromatic, right? So here between this and this, right? This is 1, 2,
Oh, I thought
3,
you was
4,
playing
5,
I
right?
thought you
This
I
is
thought you was starting to play the notes from
what?
uh
Which one?
what's that, the one with some of the third kind.
Oh. Oh, how does it go?
That's it, something like that. Yeah.
Now, if I was a little bit better music theory, if I learned music theory properly, I would have better understood which notes to hit without making a mistake. I was just going by ear. But that has kind of a symmetry to it, right? There's a frequency it kind of goes together better than right? Okay. And the point being is that in relation to each other, these things measure out to be at distances that work well together. So this is basically the doubling of this. So this is doubled in higher frequencies. This, right? And the next one is, right? So if we go up in not doubling it, but let's say we go not halfway, because that would be we go to the fifth. So what we call a natural fifth, right? Now we go back to the one. So I right. Okay, and that is really cool because it goes from the 3 to a, I guess, 3 flat. So, or you can go by numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right back to the 1 again, right? So, how the quantum and music work together, and how I think music is an excellent way to try to understand the quantum, is the way things are in relation to each other in frequency, because everything's a wave, right? The whole universe is just waves of energy.
Every word we ever say is always going to be out there.
That's right.
It just once you say it, it's there.
Does
forever.
it ever dissipate though?
Well, they're saying no.
I'm saying it does. You know why? Because if you say it here on Earth, the atmosphere knocks it down.
And that's
like a bullet.
Okay, you talk
It's
about
gonna fall
atmosphere.
eventually.
The space station, when those guys are in docking, they're going 18,000 miles an hour.
Yeah.
Okay, but the funny part is, and what I can't wrap my head around is,
right.
There's no wind. At 18,000 miles an hour, there's no wind.
There's no drag because there's no atmosphere. Okay,
I know, but it's just hard
Did you know that in space, like Star Wars, when they go pew, 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 pew?
Yeah, there's no sounds.
There's actually no sound in space. Why? Because there's no atmosphere. Sound is actually something that has to travel through something. It is a frequency, generated. Your vocal cords, this thing coming out of the speaker here starts off as an electronic, developed electronic pulse, right? And that goes through a cable. The electrons go flying through that cable at light speed practically. And then they hit that speaker cone that resonate, right? And then sends out that sound at us. And this is happening to our, perception instantaneously.
Yeah.
Right? So the point being is that, here's 2 notes at once. Wow. Anyway, the point being is that to understand how things work on the quantum, you got to understand how things work in waves. And the weirdest part about quantum physics is that spooky action is at a distance where 2 of the same particle can be at 2 places at one time. Now, time
travel.
Time is the secret word of the day. Time is
the secret word won a prize.
Yeah, right. Time is something that we observe because we make patterns out of everything. That's how we've survived this far as a species. We figured out patterns. We try to understand the world in patterns, and we've even made what our existence is a pattern of time, right? We see it linear, as a linear thing. When you go to a black hole, suddenly everything changes, and that's what kind of freaked everyone out. And when you're studying things on the quantum level, at the subatomic particle level, and how they are pretty certain that everything works as a string. And I'll show you how Michio Kaku shows people. Okay, let's say this is a string, right? All right, so that's the string. It could be like this. 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 It could be waving 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 like
But
this.
it's still a string.
It's still a string, but what makes that a different kind of particle is how it's spinning, how it's waggling, how it's wrapped up, that's what makes it what it is different from one to another. Now, I just made a different one. Now it's got 2 knots in it, you know. So when you look at things on that very basic particle level, right? You are at that like it's broken down. You see the wave of possibilities and probabilities of the universe, like the Schrodinger cat thing, right?
Mm-hmm.
And it becomes so irrational to our minds because we want to think things through and observe them as we do our everyday regular world or universe that we see, and we expect things to react and act the same way that we see them you roll a ball, it's going to roll that way or this way, you know. But you go to the magic mystery spot in Santa Cruz and you roll the ball and it's going up, and you're like, how is that happening, you know? It's not working right, you know. If you've ever been to the Salton Sea like I was in Jordan, you know, right there across from Israel and all, I mean, you float in that water and it's not water. It's like a different atmosphere. All suddenly you can't really even swim in it because you start flopping because it doesn't work like water, like a normal body. Like we have a lot of oxygen in our body and water in our body too. And you don't float the same way. And then suddenly Ron disappeared. and so what I'm saying is that when we're used to observing our universe in the way that we always accustomed to observe it, and it's different suddenly. Are you back? There you
Yeah.
go. Then we have a hard time rationalizing it or making sense. That's what rationalizing, right? Make rational sense out of something, right? So then we have to start doing experiments to say, why is it doing this? You know, they don't even have a single boat on that Salton Sea. Why? Because it'll just flop. They'd have to have so much weight at the bottom of the boat to keep it so it wouldn't flop, that it'd be so heavy just to get it in there that what's the point, you know? And they can't fill it up with the water to keep it from flopping because it just flops anyway. That's how a lot of boats fill itself with water in there, you know. So ballasting, right? Whereas it doesn't work on the Salton Sea, obviously, otherwise they would have done it by now, right? So what do you have to do? You have to like get some kind of a canoe like flat like object and maybe throw a bunch of sandbags on it until it starts to float, maybe. I don't know, you know, but it would be an interesting experiment to try to see if you can float something on that thing. I'm sure you could, but it would be interesting to see what would happen. Like if you landed an airplane onto the Salton Sea, what would happen? I'm curious.
I don't know. Try that and let us know how it worked out.
Yeah, here you go, Michael or Marcel. I'm sorry. I saw Michael from my bad vision here. Sound is an energy wave captured by carbon-based organs and electronic neurons. That's right. I think that's a very correct assessment there. Yeah. So when we're talking about quantum, now we're talking about in quantum computing and all this stuff, right? We're talking about not ones and zeros like we started off with the show, right? We started off the show with ones and zeros. That's how traditional classical computers work. We figured out a transistor that can go on off, and we're able to build very sophisticated chips that have those same little on-offs in the microscopic little atomic level, right? Through what they use silicon for, because it's very reliable. You can create perfect layers of these things, and they'll all operate, you know, using electricity going through them, flipping them on and off, you know. And then they've created code system, you know, computer system code to control these on-off things, and that's what we have in today's computer technology. Quantum computers are more like the all at once kind of thing, where you can have all these probabilities that you can weigh a query against, a question against, and get all the answers all at once. But which is the right answer? And that's the trick, right? Trying to figure out, is the Schrodinger cat alive or dead? Because that particle of I guess it's a neutrino or whatever they were talking about, a boson or something, flying into the box that the cat's in, and there's a bottle that has poison in it, and there's another bottle with the cat that doesn't have poison in it. So you have these two Schrodinger cat boxes, and in one box, the same particle that's flying through happens to break the glass, and the cat dies, and the other one doesn't break the glass, and the cat doesn't die. So it's all about these, and then there's like how many probabilities of these things can there be. Not probably describing this properly, but that's kind of how I recall them trying to explain the experiment. And then somebody else came up with another thought experiment and said, hey, but what if you have them in a box and you're outside of another box, and then you just change up that observation altogether again, because you have another observer involved. So there's not just one observer, there's another observer, and there's another observer, and then you have this multiverse of observers. So that's the quantum. That's what we're talking about. Quantized music is chopping things up in more than one number. It's could be an infinite number of numbers, right? And that's where they come up with this infinite multiverse that we possibly are existing in. But like Michio Kaku, if he actually believes that there are these actual multiverses out there in different dimensions of space-time, how would we ever be able to prove it? We probably never will. I argue that well, that could be, but what can also be is that those are all just probabilities of a universe, and we're existing in the one that is probable.
Yeah, because he made the statement that every time you make a decision, there's a new universe.
It's like
it's opposite of what you just did. Decision-wise,
book back with you that you learn about the sports games, and you can then change your now future universe, because here's the one line of time that you're on, but now you went back in time, and then now here's another line, so now there's two lines going, and then you went back in time again, and there's another three lines that are going
back to the future.
All, different probable universes that you're
alternate in 1985.
So do you ever go back in time to your same universe?
No.
Nope. You can't. And that's the thing. And then there's that other part of it, right? Yeah, Marcel.
Einstein proved that time travel was possible. We just don't have the power to do it.
And the big problem with that is like what I'm saying right now. If you did go back in time, if you could go back in time, would you be able to? You wouldn't be changing your universe that you knew, because that universe would still keep going.
Mm-hmm.
You'd just be creating another one that's parallel to it. Or does that one collapse away? Like the characters in the picture, they all just melt away and they're gone. They're no longer there because they no longer exist. Remember how they off the Polaroid, they all just disappeared, and he's looking at himself and he's starting to fade.
Which was even and a lot of people didn't catch this, but if you have a slight bit of science knowledge, it showed his older brother going first.
Yes.
It should have been reversed. Marty should have been the one going first, then the sister, then the brother. It went backwards.
He was the older one, or weren't they the older ones? No, they were.
Marty was the youngest.
Yeah, he was the youngest.
Yeah.
Oh, I see what you're saying. Yeah, you're right.
Mm-hmm.
Because he was the one that came later.
Mm-hmm. Yeah. So he would be the first to go.
You're right. They would all go at the same time, really. Right? So good point, Martin. So yeah, and he understands electronics and stuff way better than I do, obviously. But a transistor is an amplifier. It's an electronic amplifier of sorts, right? It gets electricity sent through it, and then it behaves a certain way. It either goes flip or flop, right? Depending on how much energy you put through it, something like that, right? So yeah, sound is an energy wave captured by carbon-based sound. Okay, we read that one already. All right. Yeah, dude, here's the thing about that, William De Silva, and I will tell you the secret. All right. You have to actually will it into being. And now we're starting to get into the observer part of this game. That's really freaky, weird. All right. Do you guys think that ever in my mind, I would be sitting in a room with all these crazy amps and guitars and all this gear, with not a lot of money to spend, by the way, And I'll tell you the story once again of that black one right there. Let me go grab it. This little guy right here started off. Move this guitar out of the way. This guitar right here started off as just a dream, a blue dream or a black dream. So this guitar started off coming into my possession. I might as well solo myself right now until Ron gets back. Started off with the strap. All right. I saw the strap at the Guitar Center when I had a little time to burn one day when I was doing some work in San Mateo, and I was going to go visit with my aunt, but she wasn't, we weren't ready to get together yet. And I had a good half an hour more to burn, so I thought I'd go to Guitar Center. Why not? You got a little time. All right. And I saw this strap amongst the accessories for $15, $15.99, $14.99, whatever. Normally they were $30. It was half off. It was the last one they had there. And so I bought it. And I said to myself, I said to the universe, man, universe, it would be really nice if I could find a guitar that would go with this, but it wouldn't be too expensive, And I know they make those cheap, Satriani models and stuff, under 1,000 models and whatnot. And I was thinking I could probably live with one of those, but I just kind of manifested this thing into being. What happens is about a month and a half to 2 months later, something around that, I walk into a Guitar Center and see this up on the wall with its back, with the plate on, of course, but with its back at the very top facing the corner. And I recognize the body shape. I'm like, wait a minute, that looks like a Satriani guitar, I think. And so I'm wondering, why is it facing the corner? You can't even see the tag. Somebody stuck it up there. And so I'm like, all right, this is just too good to be true, but I got to see what that is. And so I asked them, can you get that guitar down? Is that for sale? And they're like, oh, yeah. And I'm like, can you get that down for me? I think that's something I'm interested in, Ron's back. Let's bring him back in. And I'm like, they pull it off and it says 1992, vintage, 1992. I have the tag in the case, which I took back upstairs. But I can show you. I took a picture of this, right? I showed it to some people the other week. And I couldn't believe it when I saw it. And I'm like, well, I'm buying this, But I asked them, could you guys please put some strings on this? Because the strings were like black and it was dirty. It was dirty and black, and it wasn't like scratched up or nothing really, but it was like a closet clean that sat in an open garage or in a closet or something like that for a decade or more. And so I'm like, I'm buying this guitar, but I'd like to play it first. Can I get some strings on it and make sure the electronics are good and all that, right? So they went ahead and put some strings on it, and it's got a Floyd style guitar bridge on it. It's a low edge pro or low. It's one of those.
The edge.
One of the early ones. Let me see if I could find the picture. Yeah, here it is. Okay, let's see. Solo me again on this. This is the actual tag from Guitar Center, and that's what it said.
Wow.
93, they said. Now, they were totally wrong. This is a 90, because when I looked on the back, I looked at the serial number, and the serial number is under 1,000. I'm going to move that out of the way more. Serial number is under 1,000, right? And so I'm like, and then it says J, so I knew it was made, and it says tagged on there, made in Japan, right? And so I knew it was under 1,000. I'm like, that's got to be a first year model. There's no way that they made more, by 93. They had to have made more than 1,000 of these. So I'm like, it's got to be at least a 90 or 91. So I emailed Ibanez after buying it and looking it up and looking, wow. First thing I did when I went to the car, thank you, Guitar Center, for at that time. They're getting their stuff together now, but at that time, they didn't quite have it together. And this was during the COVID era too. So like there wasn't a lot of used gear up on the wall anyway. And I think an employee actually stuck it up there so no one would ask for it or see it, and was waiting for the time where he could buy it. And so, and priced it properly for himself because I looked on the Reverb, ads for similar guitars, and they were all over 3,000.
Hmm.
So what I'm saying to you is that you may not think that you can get that guitar that you think you can't afford right now, but I'm just saying, throw it out to the quantum universe out there and manifest it into being, because it worked for me. And then I cleaned it up. I did a video where, if you want to see me really, not do things properly again, like I usually do on this show, because when I do my gear and demo show, I'm no expert on any of this stuff, and Ron knows. And I admit I don't play to be, or plan to be an expert. I don't think I'll ever get expert level, because there's only so much time in life, and I've got too many other interests too. But I'd like to learn enough to know how to take care of these things and put them together well. And so with Johnny's help at that time, I took this thing apart, and we had another previous host of Johnny's going, "Oh my God, no! What are you doing? That expensive guitar, you shouldn't even have that." And like I turned it upside down, and all the saddles fell out, and all this kind of stuff happened. I don't know, because I had never changed the string on a Floyd style, locking tremolo type bridge without it just being one string at a time. I'd never taken one completely apart.
Well, now you know how to do that.
I didn't even know that was going to happen. I've always just taken the string off, put it back in, and I just observed and looked at what I needed to do and just did it, And they didn't have YouTube back in the day when I first had a similar type of bridge, a Kaler Spider tremolo bridge, So yeah, right. So, well, let me know if you use a NAG 7 for 6,000 and 600, and I'll certainly manifest it into my possession. Well, that's what I'm saying, dude. You never know when you might. I had to go out and walk around and check out used, gear places, but I think I was just lucky. But at the same time, how I can't explain that. That's a quantum universe kind of thing there, isn't it?
That's that fuzzy logic.
That universe that's the fuzzy logic stuff. That's the spooky action at a distance for lads or whatever, So that worked for me. Thank you very much, Einstein. But back to the quantum thing, is that I think that when we're talking about these universes like Michio Kaku does, I think that there's no way to prove it. It's going to be impossible to prove that there are all these multiple universes, right? I think it's just like any of these kinds of things, where to be able to get to that universe, you'd have to break this universe to get to that universe, or you'd have to break your existence in this universe to get that universe. So you wouldn't be able to get back to tell anyone anyway, kind of thing.
Yeah,
maybe, right?
That's like when everybody talked about time travel, they talked about the grandfather thing. Go back and kill your grandfather. Who in the hell is going to go back in time to kill their grandfather? How did that even start? I never did figure that one out.
Yeah, I don't know. There was probably these movies about that kind of stuff where people think about all these kind of what they call thought experiments, and they have these thought experiments about all these things, right?
Well, they call it the grandfather paradox.
The grandfather paradox.
Yeah.
Yeah, and I think that's not true. I think a lot of the sci-fi novels came post that era, because you're talking about late 1800s, early 1900s, when a lot
Jules
of
Verne
stuff, was discussed. But people did posit or think of these other, I guess, environments or universes or whatever. And when you think about it, going all the way back, you could even say the first sci-fi might have been, just people making up stuff and saying the sun is God. Because, that is like they are taking the science of the heat of the sun is what keeps us alive. Thus, this must be the power that keeps all things alive. Thus, it must be God. Now, that is fiction created from observable scientific, from their perspective. That was the early science, people trying to understand their world is science in a sense. But you have to create a language, you have to create a way to prove these things, and that's where we've taken it to that this next level now. And now we are creating tools that, like the James Webb Telescope and other things, that can help us discover even better understandings of the universe we live in. And I think what I was saying about the music thing is that the quantum is that you have, music is a very good way to explain how quantum frequency of things work, because this is the same as, they're the same note, but they're not on the same frequency. Now, if I play this, you can tell it's different. You can find it. Oh, there it is. And now they kind of work together, they're equal in a sense, right? They're the same, but not exactly the same, right? But you can have more than one. You can have. Where's my pedal? Oh, I don't have the pedal hooked up. So here are the same note in different frequencies that you can go infinitely up and down to a certain degree. And there's those thought experiments about, what if you take a piece of paper? Is there really infinity? If you keep tearing it in half and tear each piece in half up until you at a certain point, you can't tear it anymore. You're out of fibers. So there's limitations to what infinity can be depending on the medium that you're using to measure it, right? So now we're talking about the universe. Is it infinite? Well, depends on the medium that you're measuring. And we've been able to measure to a pretty good degree the amount of energy that had to have been used to occur in a certain time period to be where we're at right now. And they're able to actually measure and see the edge of our universe, right? Now, if they're really actually able to see that edge of the universe, that means that, and then they're seeing that things are moving faster and faster away from a certain place where the distance started from and then started working outward. You can measure where you are in conjunction to all these other things. You can measure, is it on a plane? Is it like a globular thing? Is it a kind of amoeba shaped thing, or what? You should be able to measure these things. Did they all expand at the same time or not? So they're doing these measurements. They're scientists that work on this stuff are measuring these things, right? But when you're talking about, is the universe infinite or not, I don't think it could be unless the energy is infinite and it's constantly going. But if it started from a big bang and then the bang ended and now we're just expanding outward, then why are we expanding faster and faster? Where's that energy coming from? Now we're talking about the dark matter and dark energy and all this stuff that we've measured a lot of what we can see in the universe. And so far we're I don't even know what percentage. Let me see.
What got me is when they said, if you look at all the galaxies, we're in our own galaxy, and then you could see what the Andromeda is our closest one. It's so many light years away. They're saying if you look at all the sand in the Sahara Desert, and each grain, one little piece of sand, is a galaxy. There's still not enough sand to show what's out there.
Yeah.
And that's
really pretty
just
amazing.
Yeah, that's
yeah. Right. Yeah.
To think that you could just go in a straight line and just continuously go and go and go and go and never get to the end of anything is just
what
wow.
I think is the most fascinating part is that the scientists mostly agree that if the Big Bang is the way that it occurred, and they're still in pretty strong agreement that that's the most probable thing that happened, that one Big Bang for this one universe that we're in happened a particular time ago. I don't know how many billion. Let's ask. When did the Big Bang happen? Yeah, I was going to say 13 something billion years ago. So 13.8 billion years ago. Now, 13.8 billion is a lot. If Elon's got way more money than that, so if you stack up a dollar bill, he's got way more than 13.8 billion, in dollars per the years of the universe. So you think if the universe is that huge and the Big Bang happened only 13.8 billion years ago, how fast did it have to expand, right? And so there are scientists that are talking about this on the quantum level, because we're talking about things going, all at once, all these things, like that. And they're talking about the energies of these things, at that microsecond instances where certain particles were then created and blah, 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 blah. Fascinating stuff. But what I find really cool about using music as a way to understand quantum and the physics is by these intervals. So you can talk about just the 1 octave, right? And there can be different combinations of just those 4 notes right there, right? And they're just the 1, the 3, the 5, and the 1 again, right? If you want to call these by numbers 1, those are different quantum numbers. But you can have different quanta, of particles and different quanta in time that these things are occurring. And that's why you can just have these 12 notes, but you're not just using those 12 notes. You're also getting these ones. So there can be more. You got 2 hands on a piano. You can only play so many of those 12 notes at once. 24 of them probably, unless you go right. So the point is that it depends on your perspective. It's a relative thing. Again, that's the Einstein genius of Einstein, is relativity, right? Relative to you and your universe, there are these things occurring that you can measure and see and understand. But can you have all the notes all at once? As far as I can push down, yeah, you can. And so that's why these spooky actions at a distance kind of thing make a little bit more sense when you think about it in the musical sense, because this C with this C, or let's use a piano sound because sounds a little bit nicer. These are both C, or we can use a synth thing. Oops. That's a weird one. That's called fantasy.
Life is just a fantasy.
Right? So I think music is a really great way to try to explain numbers, explain music through the use of numbers, because you can get that the exponentiality, if that's a real word, understanding the universe and its exponentialness, how it's whatever is happening, all right, through just a keyboard, by just trying to go, oh, you can do all these different things, and these are just frequencies that we can hear.
Yeah.
And there's all these frequencies going on out there that are beyond our perception, so we created tools to measure them. So I don't know. I mean, we kind of dipped our fingers or toes into this pool a little bit today, right?
Magic Man just, it's a possible thing. Send a signal, send it out, never come back. I probably 20 years ago, SETI, if you search for extraterrestrial intelligence, they had a program you could download, and basically your screensaver became a search tool for signals.
Oh, interesting. Yeah. What's fascinating? That's funny. Yeah, let's see what ask ChatGPT. Well, that's why a lot of scientists don't believe that there are aliens around us, or that we're, unless they found a way to break this, quantum Rosen-Einstein bridge or wormhole kind of ideology and be able to somehow fly through it or go through it or be,
that's like,
through it.
Straight lines, shortest distance. Nope.
Right. But you'd have to fold space to do that, and space has a lot of shit in it. And just to fold all that stuff that's got a lot of energy to go to your will is a pretty big stretch of a, Did we lose your mic? We lost your mic. Your mic is not, you're gone. Oh, I don't know. It's not muted on my end, so I don't know what's happening. But we lost your mic. Something happened. You'll figure it out. Yeah. So, these ideas that people posit, there you go. These thought experiments and all this stuff, some of these were just thoughts or mathematical, equations that were coming from what they were discovering. These things they were discovering these things as they were writing this stuff out. And they're like, no, wait a minute, how about this, and how about that, and how about this, and how about that, and then Hawkins gets into it, and he's like, no, there's actually radiation coming out of a black hole, and we're going to call it Hawkins radiation because my name's Stephen Hawkins, and then and leave your legacy, right? The point being is that that means that a black hole can't pull everything in. Something's coming off of it, and so there's a lot of interesting things that are happening that don't make sense to our mind yet, but we never thought, did anyone 100 years ago think we could do something like the atom bomb? I mean, holy mackerel, something that small to create an explosion that big, but we understood, the principles of energy and understanding how these things work, that certain things, it's not about the size of something, it's the energy of it and how these energies react, and if you're able to release that energy, what amazing power it has. And that explains to you the power of the sun, and why it's lasting as long as it's lasting. So there's a lot of really interesting things that are beyond our, that's right, William De Silva, beyond our everyday experiential, understanding. And quantum physics and quantum computing and all this stuff about AI, they're still trying to understand whether AI will ever get beyond being just a really good translator of information. But with quantum computing, if they're able to get a computer that can decipher these kinds of problems that they throw at it that require a lot of experiments all at once, if you want to call it, they ask it a question, they want to see how many different answers they can get, like a cancer cell, how it grows and what we can do to stop it and that kind of stuff. They're trying to develop different ways of using quantum computers to solve some of these problems, because they can do a billion petri dishes in a simulation at once, for example. But you have to be able to program this stuff in. Yeah, close, but not quite. I do recall that. They were working on it in the 30s. Yeah, and they understood the energy principle at that point too, but getting it to the point of a working bomb took a lot of collaboration. And yeah, if you guys have ever seen that recent movie that won Academy Awards, I believe, the Manhattan Project thing, that was a really, really amazing story. Yeah, and Bohr, Neil Bohr, I think at the time got it wrong. I think, or at least they argued.
The Philadelphia experiment.
That's right, the Philadelphia experiment. Yeah, just imagine how that guy's world has changed throughout his life. Yeah. Oh, okay. There's an interview of a guy, okay, who was a sheriff in the Wild West when the railroad has been built and was alive still after the moon landing. Right? Yeah, Oppenheimer. Thank you. I was trying to think of his name. Yeah.
That was a good movie.
That was a really, really, if you haven't seen that movie, you guys, very well done movie.
I watched it off of your recommendation. So
incredible movie, right?
Yeah.
The cinematography in that movie was amazing too. Yeah. That would be a cool interview to check out. So I'll have to look that one up. That'd be fun. All right. So we went extra long today. It's almost noon. I do feel a lot better now than I was so wiped out this morning. You guys I hardly got it together. My wife's like, "Are you okay?" And I'm like, "I don't know what happened." And I was like, and I didn't sleep well because of it and the noise and all that stuff. And when I don't sleep, I'm like grumpy Laz. I haven't even had breakfast yet, but coffee is keeping me alive. So I think we'll leave it at that for now, you guys, right?
Is Johnny showing up there tomorrow?
Well, that's the plan. If he shows up.
What time do you get your mail?
Usually in the early afternoon at best, maybe 2 o'clock, 3 o'clock at best. He'll already be gone from here, but he'll be in the area. Yeah. But that's going to be nice to hook up onto here.
Yep. Make it real nice.
And I'm gonna set it up through the SSL interface, which has some really nice preamps in it. It's got the SSL preamps. Hook all this stuff up, but I'm not sure if he's going to do the Tonex. If he wants to do the Tonex, but I think he's going to bring me that pedal. We're going to make a trade, right, Johnny? Here, I'll trade
I told him to take it with him.
I got something green I could trade for him. It's like a slime green color. There you go. Anyway, no, I actually
that was puke green.
I actually packed that guitar up in the case and put it upstairs because it was just in pieces down here, and I just don't want it sitting around in pieces. So I carefully wrapped up all the parts and put it in a case, and it's upstairs until I can get
Well,
to
he'll
doing that. I might do that next Thursday. I think that was the plan, is to stripe it online and do it the 4-hour marathon of striping that thing up. And then you can walk me through piece by piece how to put it back together. As you do, because you're great at that. But yeah, until next time, you guys, hope you enjoyed the show. I'm no scientist, but I love this stuff. So I've read several books, but it's hard to remember anything anymore at this age, 58, things slip through the little particles of your mind. And yeah.
You see that,
Yeah.
Liza, sitting up there? Look.
Yeah, it's beautiful. It's a beautiful thing, right? Yeah.
For
So
those of you who don't know, Liza gifted me the Randy Rhoads pedal for my birthday.
I did.
Thank you, sir.
I really didn't want to, but I did anyway. I just wanted there to be peace in the universe, Ron.
When you were at the post office and dropped it off, you did this, didn't you?
I did. I kind of went like this. Yeah. People were looking at me like, what the hell is wrong with this guy? Exactly. But then once you received it and I saw that happy smile on your face, I was like, yeah. All right, you guys. Until next time,
quantum smile.
The quantum smile. There, it never ends. It's like infinity.
There we go.
Yeah, I'm glad you enjoyed it, Cars. Well, don't forget to subscribe, you guys, by the way.
Yeah.
I'm trying to grow this channel. When I hit 1,000 subs, I will give away a guitar. And we still haven't decided what it's going to be yet. But now that Ron owes me a favor, we might be rebuilt. We might do something fun. Like I might buy, a Kramer, special or something like that. Or whatever, send it to you and you can do a paint job on it and upgrade some of the parts. And then you send it to the winner. And that way we make it something special. Or if they don't want a Kramer, if they don't want I'll say this much. I'm willing to spend upwards of around $200 for that guitar. And then including shipping it to Ron, and then he'll do some upgrades on it, and then we'll send it out. So the sooner we make this happen, y'all, the more fun it'll be.
Yes.
So spread the word, help me get to 1,000. And 1,000 might not seem like a big number to you guys, but I've been trying to hit it now for 2 years. I keep asking, like, it's been more than 2 years. I was like at 800 something. I'm like, hey, it can't be that hard to get to 1,000 from 850. And it's like 2 years later, I'm still at just 902 or 3. Where am I at? Let's see. It's so hard to break these barriers. And so 904. Thank you very much for whoever signed on recently. And part of it is because I do kind of the same thing, and I have kind of the same, viewers. And I'm not doing anything very much different. That's why I wanted to change this up a little bit, because we have to do some things differently. I got to put these lights. Oh, you guys were asking about the lights.
You need to get Phil McKnight to tell his group to come over and sign up to you.
Yeah.
That works.
Well, I want to be worthy. I want to be Phil worthy. That's why when I met Rick Beata, I says, I hope to someday be worthy of like having a chat with you. I'm not there yet. But I've got the LED light system here ready to get hooked up too. So I've got, I got plans, but it's just a matter of time. That's the thing. It's having the time for all this. And by the way, I do have
never enough
keyboard.
time.
I could actually hook a microphone up to this keyboard and do things with it, which is really fun. Like vocoder sounds and like, effects like time, delay and stuff like that. So,
echo.
I'm gonna try to make that happen, Marcel LeBlanc, because we do have a lot of viewers from Canada. So if it is something like that, then what we might do is just buy a guitar from Lone Wolf McQuaid's, I call it, because it's funny. Lone and McQuaid's, I know. From Lone Wolf McQuaid's, and you just go, pick it up or something like that. We might try to find a used one that's cool, or, make it into a show too, make it fun. If you're in Europe, it's got to be somewhere where I can buy something. So I tried to help out that one guy from India, and we just couldn't make it happen.
Thorman over, how do you pronounce it? Yeah, Thorman.
Yeah. Oh, the C, LeBlanc. Is it like LeBlanc, like that? I know I make fun, but that's because I'm American. And I'm an idiot. Anyway, I'm the American idiots. Oh my God, what's happening right now in the world? It's just insane. So until next time, you guys, be good to each other, right? Make some music. Like I like to say, the secret to tone is in your mind, but the feel comes from your heart. Put it together with musical instruments and friends and make some music and rock on. Yeah. Until next time.
Goodbye, everybody.
We'll see you